Everything that begins must someday end. A flower, a star, a world, a life, and the universe itself, vast as it is, ancient as it is no exception. For all of its hundreds of billions of galaxies, for all of its endless light, the cosmos is not eternal. It had a beginning, and one day, in a future so distant it is almost beyond imagining, it will have an end. But here is the strange part. Because scientists do not agree on how that end will come, there are several possible fates waiting for our universe. And some of them are slow and quiet, and some of them are sudden and violent, and one of them could, in theory, begin at any moment without any warning at all. So let us travel forward in time, far beyond the death of our sun, far beyond the last human thought, to witness the possible endings of everything. To understand how the universe might end, we first have to understand what it is doing right now. Ever since the Big Bang, nearly 14 billion years ago, the universe has been expanding, growing outward in every direction, carrying the galaxies steadily away from one another. And for a long time, scientists assumed this expansion was slowing down, gently held back by the gravity of all the matter inside it. But they were wrong, because the expansion is not slowing. It is speeding up. Some invisible force, the one we call dark energy, is pushing the cosmos apart faster and faster with every passing moment, and it is this force, more than anything else, that will decide how our universe meets its end. Depending on how dark energy behaves over the ages to come, the universe will follow one of several very different paths. So let us begin with the most likely one. The first and most probable ending is also the slowest, and in some ways, the loneliest, and we call it the Big Freeze, or the heat death of the universe. In this future, the expansion simply continues, on and on, forever, and the galaxies drift further and further apart until each one is utterly alone, surrounded by nothing but empty, growing darkness. And inside those isolated galaxies, the lights begin to go out, because stars are born from clouds of gas. But that gas is not infinite. Slowly, over hundreds of billions of years, the universe runs out of the raw material to make new stars, and the bright, hot, massive stars burn out first, in only a few million years, and then the smaller stars follow, one by one. The very last stars to shine will be the smallest and the coolest, the red dwarfs, stars so faint and so sparing with their fuel that a single one can keep burning for trillions of years, far longer than the universe has yet existed. But even they cannot last forever, and one by one, the red dwarfs will flicker and dim and finally fade to black. And when the last of them goes out, the universe will enter an age with no starlight at all, a vast and silent darkness, lit only by the cooling embers of dead stars, the faint glow of white dwarfs slowly turning cold into black, frozen cinders. There will be no new stars, no new worlds, no warmth, just the slow, patient cooling of everything that once burned. But the story does not end there, because even in that darkness, something still remains: the black holes. Long after the last star has died, the universe will belong to the black holes, the great devourers, slowly pulling in whatever cold matter drifts too close. And for an almost unimaginable stretch of time, they will be the only structures left, scattered across an empty, expanding void. And yet, as we have seen before, even black holes are not eternal, because through the faint whisper of Hawking radiation, they too will slowly evaporate, leaking their energy away across spans of time so vast that the numbers lose all meaning, until, at last, even the largest black holes quietly wink out of existence. What is left then is almost nothing, a thin, cold mist of particles, drifting through an infinite dark, growing ever colder, ever emptier, approaching a temperature of absolute zero. This is the true heat death, a universe that has run completely out of usable energy, where nothing can ever happen again, not a sound, not a spark, not a single event for the rest of eternity. But the Big Freeze is only one possible ending, and it depends on dark energy staying gentle and steady. So what if it does not? What if dark energy grows stronger over time? Then the universe faces a far more violent fate, one we call the Big Rip. In this scenario, the accelerating expansion does not just push the galaxies apart, it grows more and more powerful until it begins to tear everything to pieces at every scale. First, the great clusters of galaxies are pulled apart. Then individual galaxies, like our own Milky Way, are ripped open, their stars scattered into the dark. And it does not stop there, because in the final moments, the expansion grows so violent that it tears apart solar systems, then planets, then the very atoms themselves, until space is stretching so fast that nothing can hold together at all. In the Big Rip, the universe does not fade away quietly. It is shredded down to its smallest threads, and then space itself is torn open. And remarkably, this ending, if it comes, would arrive far sooner than the slow, cold death of the Big Freeze. There is a third possibility, and it is almost the opposite of the others. What if, one day, the expansion slows and stops and then reverses? What if dark energy weakens and gravity finally wins and begins to pull everything back together? Then the universe would begin to contract, slowly at first, and then faster and faster as the galaxies rush back toward one another, and the cold, dark, empty space heats up again as everything is squeezed closer and closer together. Stars would collide, galaxies would merge, and the temperature would climb higher and higher until the entire cosmos collapsed back into a single, unimaginably hot, dense point, a mirror image of the Big Bang that began it all, and we call this the Big Crunch. And some have wondered, what if that is not truly the end? What if, from that crushing point, a brand new Big Bang erupts, and a whole new universe is born, beginning the entire cycle again, a universe that is born and dies and is born again forever? We do not know if this is true, but it is a strangely comforting thought that an ending might also be a beginning. And then, there is one final possibility, and it is the strangest and the most unsettling of them all, and it is called vacuum decay. To understand it, imagine that the universe, as stable as it seems, is not actually resting safely at the bottom of a valley, but perched on a ledge partway up, in what physicists call a false vacuum, a state that feels stable, but may not truly be. If that is the case, then somewhere, at any moment, a tiny bubble of true vacuum could appear, a region where the laws of physics suddenly settle into a lower, more stable state, and that bubble would expand outward, at the speed of light, rewriting reality as it goes, destroying everything in its path, stars, planets, atoms, everything, and replacing it with a universe where the rules are completely different, and where matter, as we know it, could not even exist. And the most haunting part is this. Because the bubble would travel at the speed of light, we would never see it coming. There would be no warning, no sign in the sky, as one instant everything would be normal, and the next it would simply be gone. It could even be happening somewhere in the distant cosmos, right now. Most scientists believe this is extremely unlikely, and that even if it is possible, it may not happen for an almost endless span of time. But the mere possibility that the universe could end completely without warning in a single instant is one of the most chilling ideas in all of science. So which of these endings awaits us? The slow freeze, the violent rip, the great crunch, or the sudden bubble in the dark? The honest truth is that we do not yet know. Our best evidence points toward the long, cold quiet of the Big Freeze, but the universe has surprised us before, and it may well surprise us again. And it would be easy to find all of this sad, to feel small and fragile beneath such vast and final fates. But perhaps there is another way to see it, because every one of these endings lies trillions upon trillions of years away, in a future so distant that the entire history of life on Earth is less than a single grain of sand on an endless shore. We are here now, in the brief, bright morning of the cosmos, while the stars are still burning and the galaxies still shine, and there are still minds curious enough to look up and wonder how it all might end. And that, perhaps, is the real wonder. Not that the universe will someday die, but that for one fleeting moment in all of eternity, it came alive enough to know itself. This has been Echoes of the Universe. The cosmos is vast and patient and full of endings and of beginnings. Stay with us, and we will keep listening together.